I'm Pete Zielinski with Additive Manufacturing Magazine. I'm here with John Murray, the U.S. CEO and President of Concept Laser, a maker of powder bed, additive manufacturing, metal machines. John, machines that make metal parts through additive manufacturing, there's some variation there, differences in terminology that speak to differences in what these machines do. What is your company's process and how's it different?
At a high level, we just call it 3D printing, just to keep it simple. But as you mentioned, it's a powder bed fusion process. So this is a fully dense process where you're getting fully dense titanium, aluminum, steel parts, and so forth.
It sounds easy, and even watching the process, the part seems to come together almost by magic. But this is an industrial process, and there are industrial hazards to it. What are the safety concerns of metal additive manufacturing, and what are you doing to communicate that to potential users?
Yeah, well, you're absolutely right. Safety is tantamount. It's the most important aspect of all our systems and everything we do. It's number one. And that's driven from Frank Herzog, our CEO in Germany, down. That's a key part. And he actually has made the architecture of all the systems ATEX compliant. That's a European standard for potentially flammable or hazardous environments. We had one of our large aerospace customers do a rather extensive test. They were worried about bringing an M2 in and the environmental health and safety issues. So they put a sensor on the person's collar, one on his waist, one at the receiving station, and one at the entry door. And they ran a number of alloys. They ran the light alloys, aluminum for a while, then they switched to Inconel, and they were running Inconel. And then they checked all these sensors. And I think there was a bit of drama, right? What's going to be in there? They didn't find a trace of any powders or any soot or anything in any of these sensors. And that gave them tremendous confidence that yes, this process and the architecture that Frank has created is truly safe and can be run effectively and safely.
Yeah, tremendous confidence about a very legitimate concern.
Very legitimate. So we talk at the very beginning when we address a customer, what do you use for standard personal protection or extended personal protection, depending on what step you're doing in the process. So we go all through that with our customers, and they're sometimes surprised because people don't like to talk about it. You have to get in a suit, wear a respirator, and you have to take it seriously.
Another important issue is consistency, repeatability, quality control. What kinds of information, what kinds of data can an additive metal process provide related to quality control, and how's your technology advancing in that area?
Almost a decade ago, Frank saw the need for this. He realized you have to be able to monitor the process and document the process. Otherwise, you're making widgets, right? Mm-hmm. They're beautiful widgets, they're metal widgets, but that's all they are. So he started with a product called QM Melt Pool, and we've just released the QM Melt Pool 3D. So we're looking directly through the laser into the powder bed, into the melt pool. And we're measuring the intensity of the melt pool as well as the shape and area of the melt pool. We then compress that data, and we produce a three-dimensional model of that entire build. And that'll show if there's any porosity, if the laser went to sleep for 2 nanoseconds. And we're hoping that will help companies be able to certify their parts, whether that's for the FAA or the FDA or any internal certification processes they need. So this three-dimensional model is just another augmentation of the process to give people confidence they're building quality, flaw-free parts.
The adoption of additive is advancing rapidly. If you look forward maybe just 2 years, in terms of additive manufacturing in North America, what do you see?
That's a very good question. We have customers who are now ramping up and buying systems in groups of 20s and 30s now. So it's changing from people buying 1 or 2 machines to experiment, where now they're really breaking out into production. Right now the architecture is somebody has to go up and touch the machine, they have to start it, wait for it to finish, then come up to the machine afterward and remove the part, unpack it. We want to alleviate all that. So this is an architecture where it's the factory of tomorrow, where it's all with autonomous vehicles, with robots. Automation's key, and we've done that in our factory in Germany already. So we're moving forward with that factory of tomorrow architecture.
Safety, repeatability and quality, and even integration and automation. These are important concerns for manufacturing in general. They are the right issues for additive manufacturing as well, as this technology increasingly enters mainstream production. Thank you, John.
Thank you, Pete. Appreciate your time.